Hi, everybody. Today is Friday, March 3rd. Very quickly, if you are absent today, please make sure that when you come back, you show me your flashcards if you haven't already. They were due today, and so I need to get a grade for you. What I'd like you to do is log into Chemical Reactions 1.2, and I'm just going to take you through the lesson kind of as a summary. I won't necessarily stop and start with everything and it won't be a full length video by any means, but just to kind of introduce chemical reactions and let you know what our mystery is, our anchor phenomenon is for this unit. So the warm up activity is just asking you to consider how your life would be different if you didn't have access to clean water. And the students, we just kind of had a real quick conversation. Kids talked about different things like, of course, eating and drinking and cooking. But then we got to talking about other things that I think we just take for granted that we have water to do, like doing your dishes or washing your clothes or washing your dog, giving your dogs a bath or watering your lawn. So if we didn't have clean water, it would really impact our lives for real. And so the reason why we're asking about water is that because scientists have a very important job, and that is to ensure that our drinking water is safe. So we spent some time watching a video, and I'm going to show it to you. You guys, if you look in your digital, what's it called? Digital, let's see. If you look in lesson 1.2, your digital resources. And mine, of course, looks different than yours because this is the teacher edition, but your digital resources just goes all the way across. Look for this video here that says using chemistry to keep water safe. And just watch that to kind of get an idea of the scientists that we're talking about. So we have a message from our fictitious Dr. Samara Young that we are working with, and she's a lead chemist. And she says, last week I received a call from Alexa Anderson, a resident of Westfield. When she turned on her faucet for a glass of water, a strange reddish brown substance came out. She called a few of her neighbors and found out that the reddish brown substance was coming out of their water pipes too. My lab uses chemistry to identify unknown substances, so I went to Westfield to take some samples. I took a sample of the water coming out of the pipes and another sample from the well where the neighbor's water comes from. I analyzed the samples and made an interesting discovery. The water coming out of the pipes contains the mysterious reddish-brown substance, but I didn't find any of the reddish-brown substance in the water samples that I took from the well. However, I did find something else. It appears that some fertilizer from a nearby farm seeped into the water in the well. We need more analysis in order to identify the reddish-brown substance, but unfortunately my lab is pretty busy with other projects right now. Student chemists, I need your help to get to the bottom of this mystery. The residents of Westfield need answers. Let me show you this diagram real quick. This is our anchor phenomenon. So the residents of Westfield found a reddish-brown substance coming out of their water pipes. Okay, so Dr. Yoon took samples of the water from Westfield's well. So she went into the houses, turned on the faucet, took samples from those water pipes. See, the thing is, though, when she went back to the well, which is where the water comes from, she didn't find any of the reddish-brown substances. But she did find some fertilizer. And there's a nearby farm that she thinks might have something to do with the origin of that fertilizer. So this is our problem. We're trying to figure out what's going on, not necessarily what's in the pipes, although that is kind of a question, but like what is happening here? So I had an actual sample in class, and when you come back, I'll show it to you. But I've got a sample of the well water, and then I have a sample of the water from the pipe. And I want you to notice that the water from the pipes has that reddish brown substance, but the water from the well doesn't. In order to analyze the issue of the water for the residents of Westfield, we need to ask ourselves two questions. We need to ask ourselves, first of all, how do new substances form? If we've got two things that look different, are they different? And if they are different, how did that happen? Because the water comes from the same place. And then our chapter 1 question is, what is the reddish brown substance in the water? So there are going to be actually 3 claims that we're going to be considering for this unit. Okay, the first one is claim number 1, that the reddish brown substance is the same thing. It's the same substance as the substance that makes up the pipes. And claim number 2 says the reddish brown substance is the same substance as the fertilizer. And then claim number 3 says the reddish brown substance is not the same as either the fertilizer or the substance that makes up the pipes. We just kind of had a conversation real quick. What are some initial thoughts? What are some questions that you might have? What are some kinds of evidence that you would like to see to help you make a better choice of a claim? So then we had on our tray, we've got these 3 vials, and the vials are sealed, so you can't open them. And then the first one has this kind of, it has this kind of material in it that is from the water pipes. Dr. Yoon broke down a piece of the pipe at her lab to make it easier to examine the substance. And so the kids took a look at that. And then there's another vial that had this white kind of substance in it. And this is a sample of the fertilizer that Dr. Yoon found in the water. So this is from that actual well. She evaporated the water in order to observe the solid all by itself. And then this is a sample of the reddish brown substance that Dr. Yoon found coming out of the water pipes. So she filtered the water to observe just the reddish brown substance. And the way you do that is, if you've got a sieve or like a colander or a strainer that you would use for pasta, you can get some that are just really, really fine. Like the holes of the mesh are not very big at all. And so you would pour the water in that, and then whatever's left on the sieve, you could dry that to get all the excess water evaporated, and then you're left with this reddish brown substance. And so I wanted to have the kids write down some scientific observations from those 3 vials, and I demonstrated how to do that through the use of my 5 senses, and I used the well water and water from the pipe to kind of get them started. So the first thing is, anytime you look at a substance and you have no idea what it is, we want to keep track of the physical properties of that matter. The first thing I want to do is I want to find out what phase is it in. So I made an observation that the well water was liquid at room temperature. And then the easiest thing is kind of look at the color. And so the color is clear or it's transparent. Okay, so far that's kind of all I could look. If I wanted to be really detailed, I could look very closely and identify if there's any kind of substance that's floating in the water. In a different situation, I would take the lid off and kind of do that whole wafting thing, and I would identify if there was a certain smell to the water. Like sometimes water can have kind of a sulfur smell to it. It smells like rotten eggs, or maybe a very metallic smell to it. But that wasn't something that we could observe today. The second vial that I demonstrated was this water from the pipe. And so again, I wanted to talk about the phase. The first phase that I noticed is that it was a liquid at room temperature. But if you look real carefully, you can see that there's a darker kind of settling of a solid down at the bottom. And so I said there were solid particles resting on the bottom. And then the color is reddish brown, but you'll notice that the color isn't consistent all the way through. And in fact, the longer I let it sit, the solid particles seem to settle at the bottom, and then the liquid gets a little bit more clear. If I shake it up, then it's all mixed together, but it does separate. So that's kind of interesting. Again, I could have taken the lid off and done the wafting to smell it. I could have put my finger in there and kind of rubbed my finger and my thumb together to see what the texture was, if it was gritty or if it was sandy or if it was sticky, like a muddy kind of a substance. But I didn't do that. So the kids had those 3 vials on their tray, and in their table partners, they observed each of those samples and talked about what they observed. And we're just practicing our observation skills. And so after each one, I asked the kids to kind of talk about it. And we kind of did these all together. So when we looked at the pipe substrate, what we noticed, and I kind of actually what I'd like to do is maybe not tell you about them. And when you come back, you're going to look at these on your own and kind of make some observations. But they are very different. They are not the same thing at all in appearance, in physical appearance. The vocabulary term that we went over today is property, and that's something that can be observed about a substance, such as its color, smell, or boiling point. Other examples of physical properties would be grain size. So if you think about different why can't I say it? Like sand particles. It's a type of rock. Why can't I say it? Igneous sediment. Good grief. Different types of sediment. So there are grains of sand that are really small. It might be kind of pebbly, so it might be a little bit bigger. So what is the grain size? We use the terms fine grain to describe real small size. We use the term coarse grain to describe larger size. We even use the terms uniform or ununiform. If the size of the grain is the same size, then we would say it would be uniform. I want you to see if you can look real closely at the pipe substance. And if you look at it real careful, right in the very middle, you're going to see kind of a bigger piece. And then all the other pieces below, they're kind of different sizes. So this one we would consider being ununiform or not uniform, meaning they're different sizes, and kind of a coarse grain because we can definitely see each and every individual sized grain of this. The fertilizer is white. It's kind of grainy. It's uniform, and I would say it's more fine-grained or small, kind of in between. And then the reddish brown is more like a powder, and so that is very fine-grained. You can't even see the individual pieces. And then, of course, the colors are all different. Okay, so chemists rely on properties that can only be observed under special conditions like melting point and boiling points, because as you know, when you were doing your research on your element, different substances have different melting and boiling points. And so this is a property that could be used to help identify a substance if everything looked the same and we just only had that one property that we could go by, then we could identify a substance based on that. So the melting point is, of course, the temperature at which a solid will begin to melt and turn to liquid. And then the boiling point is just the opposite. So remember, the melting point is when kinetic energy is being added to the substance. And boiling point is when kinetic energy is being added to the substance. So the liquid will begin to boil. We could talk about melting points and boiling points, but if the kinetic energy is being added, it's melting and boiling. But if it's being taken away, then this would be the freezing point, and this would be the point of condensation. Just remember, is the energy being added or is it being taken away? All right, so then we just kind of talked about the different properties of the substance. We determined that they were different. There were some properties that might be considered the same, but for the most part, all the properties of these substances were different. And again, when you come back, I want you to take a look at these vials and make some observations for yourself. Okay? We talked about properties that we were unable to observe. One of the ones that I think that would be really interesting, and actually I did as the kids were looking at these, I walked around and I did the lid. I didn't let the kids do it, but they were able to look at the grains a little bit easier. We used a magnet even, which was interesting. So anyway, I'll have you take a look at that when you come back. And then we just had a discussion about whether we thought that there were any observations of the substances that supported the claims so far. And some interesting things. Some of the kids said that the reddish-brown substance is the same as the substance that makes up the pipe, because if you look at the pipe substance, you can kind of see it's mostly gray and like black, but there's some brown in there too. And so some of the kids thought that it would be like this was actually this. So interesting thoughts. Okay. As far as the reddish brown substance that is the same as this fertilizer, that's hard to say because the color's not there, but the texture is closer than this texture right here for the pipe substance. And then the reddish brown substance is not the same as either the fertilizer or the substance that makes up the pipe. And everybody kind of was under the understanding that maybe they thought it was a part of something, but they just didn't quite know yet which one it was. So more to come on that. That's all I had for you today. Have a great